So hi guys, how are you all doing? I hope everything is going fine. Today in this video we are gonna dive into ASB or Enterprise Service Bus, and this is brought to you by my classmates Vanessa Brenes, Daniela Montenegro, David Vega, and my person Frank Benavides. In this video we are gonna talk about these topics that are here in the slide, and we are gonna be seeing each one by one. So let's start with the description.
Architecture description. With the great increase in the use of different web services in companies, organizations increasingly need new tools that allow them to interconnect the different applications and services they use. The language in which the web services are programmed on various occasions tend to be different, as well as those in which the applications are developed. In addition, these applications often require multiple services and interconnections with other applications that manage the company, which generates major problems of complexity when it comes to direct communication between these different components. In addition to this, high coupling, rigid designs, and little flexibility of systems are being promoted. To solve all these problems, ESB was born, which is a software architecture model that works as a mediator between applications and services, positioning itself as the only point interaction between them and in charge of abstracting the complexity of the exchange of information, enabling the communication between systems over any protocol. That is, it is in charge of translating the message from one language to another to make it reach the destination application in its native language. It is a fundamental component of service-oriented architecture. Advantage and disadvantage. Advantage. The ESB provides a low coupling environment, high flexibility and reusability, thus greatly facilitating maintenance. It provides a series of standardized, commonly used integration components, ready to be used in a short time, which significantly reduces the implementation times of new services and applications. It allows message routing, since when one application or services require another, the call is not made directly. It is made through the ESB, and this in turn is programmed to send the desired invocation to the destination application, thus assuming a first level of decoupling between both applications, called independence. With the implementation of a ESB in an organization, each of the applications or services that are running can use the data transfer protocol that suits them, so that if the protocol of the one that makes the request and the one that receives it do not match, the ESB is responsible for making the necessary conversions to successfully interconnect them. With implementation of the ESB, the same services offered by an application can be invoked in different business contexts. In this way, a company can take advantage of a web services in different situations and increase its flexibility. Disadvantage. Increased overhead latency caused by message passing through the ESB extra layer, specifically when compared to point-to-point communications. Qualified personnel in middleware analysis are required to configure, manage, and operate an ESB. This type of product is usually not exactly cheap. It takes a large company with many services to develop and manage to offset the expense. Requires constant message version management to ensure that the intended benefit of flexible pairing is being released. The ESB becomes a single element of failure. If it fails, the applications and services that were programmed to intercommunicate through the ESB will not have that communication.
Now, in the next topic, we will talk about the relationship between the ESB and SOA. As a first step, we will explain what service-oriented architecture consists of. Service-oriented architecture arises from the need to build a composite information service, where heterogeneous databases are integrated into an intelligent system aiming at optimizing the integral communication of a company. SOA has a versatile information structure where it is possible to consult different data sources. giving you the ability to evolve adapted to the demand for a company's services. Improving response levels your customer when they interact with services of business information. And it is possible to say that SOA is seen as an architecture that centralizes all the redundant information flow to decouple the system from each other and reuse and integrate the existing assets. In this example, we observe an architecture with a silo approach. In this case, the functionalities are duplicated in the different applications, as shown in the image. In this other example, we see how the silo approach is avoided by means of a SOA approach, which allows common functionalities to be shared across services, as shown in the image. And in this other image, it is possible to observe the internal SOA process. This is based on a request and response mechanism where a consumer involves a service provider through a network. Therefore, the consumer must wait until the provider finishes operations and responds. Now that we know about the service-oriented architecture, it will be possible to establish what relationship exists between the ESB and SOA. To contextualize it, it is important to mention that currently, the minimum number of commercial applications are found in an isolated way, since it is stated that by being connected to each other, it is possible to generate an integrated solution that provides value to the company. SOA is an architecture that has the challenge of performing complex integration, however, it is solved by using ESB. Also, when an SOA is implemented, the services do not normally interact directly with each other, since the interaction is performed through an ESB that prevents the information system from interconnecting in a way that is not convenient. It is possible to say that the ESB is related to SOA in terms of connection, since through the ESB the various services providers are connected. And it also has the ability to reformat information so that it can be adapted to different applications. In other words, it is possible to explain it by saying SOA has a goal to be achieved, while ASB has a tool that will be used to achieve this goal. This because it will allow the integration of software applications through the exchange of data that occurs with the Enterprise Service Bus. The Enterprise Service Bus is also considered as the backbone of service-oriented architecture and is seen as an ASB that is mostly featured in architecture that are based on application integrations. When implementing SOA through ESB, it is intended to avoid having a spaghetti architecture, which occurs by having decentralized communication that creates difficulties in the transfer of data within systems, such as having a strong coupling, misuse of standards of communication, as well as threats that are intertwined in an informal and disorganized way. This can be seen in the example presented in the image. The problem seen in the previous example is corrected by a service-oriented architecture that uses an enterprise service bus. Since with the bus communication is established between different application processes, with purposes of integrating and decoupling the information through an SOA. This can be seen in the example presented.
The following is an ESB success story. Neuron is ESB-based software that offers modernizing and integrating a business in a fast, cost-effective, and easy way. Neuron ESB is an easy-to-use yet powerful enterprise service bus that simplifies messaging and web service enablement to accelerate the adoption of service-oriented architecture. Neuron can be integrated with cloud, SAP, IoT, and many others. Companies that want a simple, agile, and low-cost integration solution choose Neuron ESB. For example, Fidelity National Financial or FNF. This company is one of the companies that was used Neuron ESB to improve its business process. FNF is a leading provider of title insurance and transaction service to the real estate and mortgage industries. This company generates approximately 8,469 billion in annual revenue in 2019. But what happened with this company? Okay, FNF had a challenge because existing messaging system was too resource intensive and susceptible to lost messages, making it difficult to guarantee message delivery to regional workstations. But the solution is this. Capitalizing on their existing .NET skills, developers use Neuron ESB's implementation of reliable pure channel multicast protocol to easily maintain and manage real-time messaging traffic across 1,500 regional workstations with minimal cost or additional infrastructure. What are the benefits? Okay, with this implementation, the company reduces labor costs and boosts operational efficiency. Also provides instant visibility as orders populate queues in real time. Bolsters user confidence by eliminating lost messages, and it gives users flexibility to execute tasks quickly. These are the words of the vice president of the company. And with SUS implementation, operational efficiency is increased and it is possible to provide better customer service. And this is the principal benefit because it offers our customers a reliable and quality experience. Future projection. What is expected of the ESB in the future? Well, in technology world, there are changes every day. Year after year, new trends emerge. In the case of the ESB, it is a relatively new type of architecture. It is gaining popularity in the market. For example, according to a market intelligence and advisory firm, in 2012, the number of connected devices was 8 billion. But by the end of this year, the number of connected devices will reach 50 billion. Only 8 years, and the difference is big. But what happened with this? Why IoT? Okay, as the number of devices connected to IoT increase, device and data integration also become complex. These connected devices can present numerous messaging and integration challenges. Therefore, organizations must invest in efficient application integration solutions. For example, the next image shows the growth rate by region expected from the ESB from the last year to 2024. In Asia countries, the use of the ESB is more common every day for the reason. For example, Korea is one of the countries with the most IoT devices. With ESB, it's possible to obtain a flexible and scalable infrastructure with which companies can work quickly and efficiently. In addition, the characteristics of software market make ESB an excellent tool. So its disappearance is not a near event.
So in this last section, we are gonna take a deep look in how an enterprise service bus works. For this example, we're gonna do something like this picture that is shown right now. We are gonna make a little example to comprehend and to see how exactly it works. We are gonna have a backend service that is gonna be providing info. We're gonna have a REST API, which is gonna handle all the communication, and this is gonna be all integrated into the service bus. And at the end, we are gonna have a requesting client that is gonna ask for some information, and it's gonna get a response back from the backend service through the enterprise service bus. So let's see it. So for this example, we're gonna be using an WSO2 enterprise service bus solution because it is completely open source and it is pretty much easy to work on. So let's open the IDE. If we come here, just like the best example on how it is done, we have the API, and this is the specific space for the response. So basically what we do is we send the first request, we log it just to see what it is doing, and we send it through an endpoint that we defined before, that it is called query doctor AP, the endpoint. So basically this enables the browser or any program basically to go to this URL template and pass all the necessary values to get the information that it needs. So that goes there, and at the end it is basically just sending the response. And here you can see all the configuration and all the files that were needed to do this. Also, it is important to notice that right here we have a little server that is running behind all these, basically creating the magic. So if we open some command prompts, we are gonna be using this jar file that is called hospital service, and it is gonna contain all the information that basically the API and the client are gonna be using to get all the information. This is basically the main service with all the information. So we just run it, and there it is listening on the server on a specific port. And here in this other window, we are gonna be basically going through this direction, which is the IP direction of the server that was created by the Integration Studio editor that was basically needed if we wanted to use that solution that we showed before. So we go to that specific direction or IP direction run a specific port, and here we're gonna start by introducing all the specific structure for the API to get all the information from. So basically we can see here we are using the endpoint for doctor, and we are gonna ask for the doctors that have surgery. So if we run this line, we are gonna get a response from the service, and here it is basically a JSON format with all the specific info of all the doctors that are located in the category surgery. And here it is all the info that was basically loaded from this service that was running inside of this specific structure that meant to show how the enterprise service bus works. And this was only like a specific and a really short introduction on how that works. But as shown before, this is only one of the options if you want to integrate an enterprise service bus into your application or into your architecture. Mainly, we can look into some specific alternatives like the AVM, that is basically one of the more popular ones. So this is going to be
And finally, the conclusions. The ESB has come to solve the problems in terms of integrations, since with its architectural approach it has become a mediator between applications and services, which has allowed interoperability in heterogeneous environments. The use of ESB makes it possible to simplify business integrations through the services it provides at the transport, event, and mediation level. With it, it is possible to connect the communication and integration between the necessary services in an event-based architecture and in a service-oriented architecture. As organizations shift the information technology infrastructure to a hybrid cloud approach, there is a chance that they will transfer at the ESB parent level. Has that chain add transformation to modernization that cloud-based organizations need?